In this video, we're going to look at this problem where we're going to find the current through each resistor and voltage across each resistor and the power involved in the circuit as well. Now you'll notice if you've watched my two previous videos, I'm using the same battery and the same three resistors here. But in the first video, you can find that we added all the resistors in series. In the second video, we added all the resistors in parallel. But now you can see that it's not quite so simple here. There's a combination. There's couple resistors connected in parallel, and then that combination is in series with another resistor. So we go about and solve it using the same technique we've been using. Here I've just redrawn the circuit. The first step I always want to do is find the equivalent resistance. How do I do that? Well, notice these two are in parallel. So if I'm going to redraw the circuit, these two I would like to combine first. So I'm just going to redraw the circuit, give myself a little more space here. Okay, so what I am going to do here is take those two that were in parallel and combine them into this one resistor called RA. You can label it as whatever you want. I just tend to use something like RA as a placeholder name. So because R2 and R3 are in parallel, we would combine them like this. And if you plug in the numbers, you can see here R2 is 4 ohms, R3 is 6 ohms. You would end up getting 2.400 ohms. Now, looking at this one, you can see, if I'm looking here, these two are connected in series. So what I'm going to do now is combine these into one. So combining these two then in series, I'm going to go down here and you can see my final equivalent resistance will be R1 plus RA, and that's going to give us 5 ohms. So just to recap, we've started and looked at the easy parallel combination, combined it, then went down to the one equivalent resistance right here. At this point, if you remember your circuit theory, because it's one resistor, the voltage gain of 6 volts across the battery is going to be the same 6 volt drop over Req. And that means it's going to be equal to the battery voltage, and now we can use Ohm's law to find the current. So the current coming out of the battery will be the same as the current that goes through the equivalent resistance. There's only one path. So using Ohm's law, using the battery voltage over the Req, plugging in those numbers, you can see that's going to give us 1.200 amps. And as I've done in previous problems, I'm going to add that to my data table that keeps track of all the answers in a much more compact and organized way. So with my data table here, I know that this is going to be 1.2 amps coming out of the battery. And I also know the voltage rise of the battery is 6 volts. There. All right, let's keep going. So at this point, we finished our breakdown of the circuit and we found everything we need to go. What we are going to do is start building up the circuit again. I am going to go back to this previous diagram here. And I usually do take the original diagram here that I used here and do the work on it. But in order to make it clear, I'm just going to show it again here. Now, we know the current coming out of the battery is 1.2 amps, and the current going through here, then through here, and back to the battery is all going to be 1.2 amps. So notice here, I1 right there, this will be IA. And notice because it's a series circuit, I1 will equal this IA will be 1.200 amps. And now, what else I can find from this is I can use Ohm's law to find V1 and VA. So using Ohm's law, delta V1 can be I1 R1, and delta VA can be IA RA. And we know the currents are the same at 1.2, and so if we plug in our numbers, we can get the values of delta V1 and delta VA, and that's going to be 3.12 volts and 2.88 volts. And notice these two combined with each other add up to 6 volts of the battery, just as we'd expect. So we found some answers here, especially this one, the voltage across R1. So I'm going to go up and put that in my data table. So I just saw that for R1, the voltage drop is going to be 3.12 volts. And I saw the current through it was going to be 1.2 amps. All right, we still have one more step to go because we need to find everything for R2 and R3. So we've got delta VA. We need to go one more step on our buildup. And there it is. So because VA, or combination A, represents R2 and R3 connected in parallel, one of the things we know about parallel circuits, this voltage drop here, delta V2, and this one, delta V3, they have to be the same. They're in parallel, and it's going to be the same as delta VA we did in the step before, which means this is going to be 2.88 volts. And now we can find I2 and I3. And just to remember that we're going to have 1.2 amps that way. So let's use Ohm's law. So using Ohm's law, we can find I2. So I2 is going to be delta V2 over R2. I3 will be delta V3 over R3. And so if you plug in the numbers for all of this, what you're going to end up getting is I2 is going to be 0.72 amps, and I3 is going to be 0.480 amps. And notice the two of these added together is going to be 1.2 amps, just like we expect. So with these values, let's go and put them in our data table. We've now successfully built up our circuit. Okay, so we saw R2 is going to be 0.72 amps and R3 will be 0.480 amps. We also saw that the voltage drop here on the two was the same at 2.88 volts. Then we can just use, as we did in the other ones, P is equal to I delta V. And so we can just use the two values in the row to multiply and find the power dissipated for each resistor. In this case, you're going to get, for R1, 3.744 watts. For R2, you're going to get 2.074 watts. For R3, 1.382 watts. And 1.2 times 6 volts for the total power delivered. This is going to be 7.200 watts. And just to make sure the conservation of energy works, if I add these up, I get 7.20 watts. So yeah, everything adds up nicely. All right, that's the end of the video. Thanks for watching, and if you have any questions about doing circuit analysis for simple resistive circuits involving combinations in series, parallel, or even a combination of combinations, please feel free to come and talk to me. All right, thank you for watching, and have a great day.